Welcome to video 3-5. There are some worksheets on Blackboard. This one you will notice as the Box and Whisker plot worksheet. Let's do a solution to it. The first step, we wish to find the median in the first quartile and the third quartile. And of course, it will be much easier to do that if we first order the data. And so that is what I have done. I have not only ordered it, but I have written down the index, the position of each data element. And you can see that there are 15 pieces of data. You might note that that's an odd number, and so there are some tricks available for us to find the first quartile and the third quartile. First of all, let's find the median. You remember that the median is halfway through the data. We use the formula n+1 to get the exact index. Remember, this once again comes from the percentile formula, the 50th percentile, p out of 100 times n+1. This is the formula we have been using all throughout Unit 3. And the median, you know, is the 50th percentile. If we put 50 in for p, 50 out of 100 is the same as 1 out of 2, or 1/2. And so we have 15 pieces of data. 1/2 of 15 plus 1, there'll be 1/2 of 16, or 8. The median is in position 8. And so the median of the data is 44. Next, the first quartile. Do you remember that when we have an odd number of pieces of data, you can find the first quartile as the median of the lower half? Can you see the middle number of the lower half? The first quartile? The first quartile is the number 40. Of course, the first quartile, 1/4, the position of the first quartile, 1/4 of the way through the data, 1/4 of n+1, which is again 16. 1/4 of 16 is 4. The first quartile would be in the 4th position, but it was easy enough to do the median of the lower half. We do always have the percentile formula available to us. The third quartile, the median of the upper half. It is easy enough to see that the median of the upper half is 52, and so the third quartile is the number 52. Of course, we could have used a formula like this to find the third quartile. We would be looking at, instead of 1/4 of 16, we would be looking at 3/4 of 16, and that would be 12. And the third quartile would be in position number 12, 52. And so those are some numbers that would go into our 5-number summary. The first quartile is 40, the median is 44, the third quartile is 52. It is not so hard to find the minimum. The smallest number, if we look at the ordered data, is 2. The largest, or the maximum of the data set, looking at the ordered data, is 112. And so there's our 5-number summary. Particularly easy if we have an odd number of data elements. Part D, the interquartile range. IQR, interquartile range, Q3 minus Q1, 52 minus 40, 52 minus 40 is 12. That's the distance between Q1 and Q3. We're eventually going to graph a box and whisker plot. Q1 is at 40. We start the box at 40. And then we have to go over to Q3, 52. We have to go over to 52. Where is 52 here? Did you notice that from 0 to 10, there seemed to be 1, 2, 3, 4, 5 steps. To get from 0 to 10, we have to take 5 steps. 10 divided by 5 is 2. It looks like each step is 2 units. The first step is at 2, second step is at 4, 6, 8, and then we arrive at 10. And so where is 52? 52 is 1 step past 50. 52 is 1 step past 50. 52 is the third quartile. So the box begins at the first quartile, or 40, and goes over to 52. We can complete the box. The median is at 44. That's 2 steps from 40. We put a line in the box to show where the median is. And we're almost finished the box and whisker plot. However, we need to know how to draw the whiskers. The minimum of the data is at 2. That would be here if I mark it with a dot on our graph. The maximum of the data, 112. There's 110, and 2 units further is 112. I'll mark this location with a dot. It looks like our whiskers would be quite long if we went to the maximum. Possibly also if we went to the minimum. We know that our whiskers cannot be too long. How long can they be? Remember the formula? Remember the distance? 1.5 times the interquartile range. The whiskers can be 1.5 times the interquartile range. We computed as 12. 1.5 times 12 is 18. The whiskers can be 18 units long. We have formulas for the lower and upper fences. We can remember these formulas and work with the interquartile range and the first quartile and the third quartile. Let me help. It might be a little bit, but it might be a little bit helpful instead just to work with the plot. We can fill this in later to check our results. The third quartile is at 52. 52 plus 18. That's 70. The upper fence would be at 70. That's the result we will get for the upper fence. The lower fence. The lower fence starts at 40, and we subtract 18 this time. That gives us 22. The lower fence is at 22. And we see that the minimum and the maximum are outside of the fences. So the whiskers cannot go to these values. The whiskers would be too long. The lower fence starts at Q1, which is 40. We subtract 1.5 times the interquartile range, which we have computed to be 18. The lower fence is at 22. The upper fence starts at Q3, 52, the third quartile. We add 18 this time. 70 is the value of the upper fence. So we have a couple of outliers so far, 2 and 112 will be outliers. Where do the whiskers end? put the lower fence into the data at 22. In the ordered data, where does 22 fit? That would be between 2 and 32. And so the first piece of data inside the fence would be at 32. 30 plus 2. That's where our lower whisker, the left-hand whisker, will end. The right-hand whisker, the upper fence is 70. Let's put it into our data. Where does 70 fit? Between 68 and 82. The whisker ends at 68. 68 is 2 units below 70. We'll put a dot there. 68 is a data element, and that's where the right-hand whisker ends. And there is another number, 82, which sits outside of the fence. That is another outlier. And so we have completed our box and whisker plot, and we have 3 outliers.